reduced row echelon form both on your calculator. We're going to look at both reduced row echelon and just plain row echelon. If you're going to use your calculator, I wouldn't be using row echelon form, as you'll see why in a minute. But Math Excel is going to ask you for row echelon form versus reduced row echelon form. We'll talk about the differences between those two. So you need your calculator. So I'm going to clear out my calculator over here. And so the first thing we're going to do is you're going to write yourself some notes. So we're going to start off. If I can actually type without looking like a kindergartner. You're going to input. That's a 1. This right here, that's a 1. It's number 1. Input. It says input. Oh, for Pete's sake. It says input the system. Shh. Stop talking and you can listen. Input the system into your calc as an augmented matrix. So we talked about the augmented matrices on page 1. Yes?
Why don't you use the text box?
Excuse me?
Type it out.
I don't have a text. Shh. I don't have a text function on this particular application. Otherwise, I would. That's not what that's for. Nope. All right, so that's our first job. And so our augmented matrix would stop talking. It's an easy fix. Keep your mouth closed. So we're going to write our augmented matrix so it doesn't look horrible. You're essentially going to be dropping all of your x's and y's and your equal sign. And so we want a 3x4 matrix. So your first row for equation 1 would be 1, -1, 2, -3. Your second equation is 2, 1, -1, 0. And your third equation is -1, 2, -3, and 7. So we're going to input that exact matrix into our calculator over here. I'm going to move this over so we can see it. And you're going to go to second matrix. And we're going to scroll over to edit, and you want to edit matrix A. And what's the dimensions of this matrix? 3x4. And then enter your rows across. Second matrix, and you scroll over to edit. Did you find it? Yeah? So these matrices here should look identical. I'm going to wait till everybody's input that. And I do expect to see this on your paper. I need to see what you input into your calculator and then what's going to pop out. Because what took you 5 to 15 minutes to solve, oh, terrific, over the weekend. Let's reopen. Hopefully I don't have to re-input the matrix. I probably will. Ah, technology. Oh, of course it didn't save it. Okay, so then from here, let's go back to some notes. So your step 2, only for purposes of Math Excel are we going to talk about what is row echelon form, which is what you were doing all weekend. You were getting your systems into row echelon form, but there's an easier way in your calculator, and you'll see here in a minute. So row echelon. And we're going to write the difference between row echelon and reduced row echelon. So the purpose of row echelon is it gives you the equations prior to reverse substitution. And so that was our point of doing row echelon form by hand, was we could get to the point where we were going to get z equals some number and we could do reverse substitution above. So we're going to actually find that on our calculator, and here are your instructions. So if I were you, I'd write them down. So you are going to do second matrix then you're going to do an arrow key. So within the matrix menu, you're going to scroll over using your arrow key to the math menu. And then from there, you're going to scroll down to REF. And in fact, let me put that in a different color. And then you're going to do second matrix again. And this is all from the main screen, by the way. And then you're going to hit enter. And you're going to hit enter again. So there's your instructions for the calculator.
Is that enter twice?
You're going to hit enter twice. So then over here on your calculator, I want you to do second quit so that you're back at the main screen. So all of these directions are according to the main screen. So, and if you don't have your calculator with you, you definitely better be writing down those instructions, because it's your job to bring your class so you can use it. All right, so you're going to do second matrix. How did I get that? That would be incorrect. Try that again. Second matrix. And we're going to scroll over to the math portion, and then you have this list of stuff. So you're going to scroll down with the arrow key until you see just REF. There is one that says RRF, and you can stop scrolling, and you can see it right here. We don't want the RRF right now. That's really the more useful one, but if your Math Excel asks you for reduced echelon form, you want to use just the REF. So let's choose that one. So hit enter. And then your calculator is asking you to name which matrix do you want to find reduced, or do you want to find row echelon form for. So do second matrix, and you're just going to name matrix A. So hit enter. Get in the habit of ending those parentheses and hit enter again. This one has decimals. How do you deal with that?
Regression.
So you're going to do math, enter, enter.
Wow.
Yeah. So then you're going to write that on your paper to show what popped out of your calculator. And so let's talk about what that means. So down here, you're going to put in the matrix you just got. Let's go. Ellie, come on.
Sorry.
And so what this has given you is your equations. So from here, remember, this is row echelon because I've got 1, 1, 1s in a diagonal, and then below that diagonal are all zeros. And that's what you were striving for by hand. Only the calculator did it for you. And so from here, we can take out each of these rows and write them as their actual equation. So for the first row, we have 1x plus 1/2 y minus 1/2 z equals 0. We have no x on the second row, but we have a y minus 7/5 z equals 14/5. And then we have no x or y, but we do have a z equaling 3. So then from there, we could use reverse substitution and then go find x and y going above. Well, why do that when your calculator will actually do the whole thing for you? Okay, so I personally wouldn't use that, but your Math Excel is going to ask you for that. So really what you want to do, step 3, is you are going to find reduced row. So you're finding reduced row echelon.
I like your nails.
Thank you. Yeah. What's wrong? You good? Okay, so the difference between row echelon form and reduced row echelon is phenomenal. Reduced row echelon actually solves the whole problem for you. It solves the system for you. The last column is the solution. So for instance, we're going to write the directions to find reduced row, and they're nearly identical to the directions you just wrote for row echelon, except you're going to look for RREF. So we're going to do second matrix. You're going to scroll to the right to get to the math menu. And then you are going to be looking for RREF, which is right below REF. And then you'll do second matrix. And then you'll do enter, enter. Okay, so then let's go ahead and do that. well, let's go ahead and I'll keep that so we can see that part of it. All right, so then over here, I'm going to clear this out. We're going to go to Second Matrix, scroll to the Math menu, and then scroll down. There's your REF, but we want our REF, so then hit Enter. And then they want you to name the matrix, so Second Matrix. Hit Enter to name Matrix A, get in the habit of closing those parentheses, and hit Enter again. So let's write down how that one looks different. Because this matrix looks like this. So what do you think the difference is between reduced row echelon and just plain row echelon? Well, that's partially it, Ryan.
Like, it shows you the process.
It has the ones that go diagonal.
You got your diagonal ones.
And then all the ones that equal something.
Well, notice that all the zeros that are down here, normally row echelon form would just be those diagonal of ones and all the zeros down here, but what do you notice above here as well? There's zeros above the diagonals of ones as well. It's not that it solves it for you, it does, but I'm asking you to look at the difference between row echelons matrix and reduced row echelons matrix. You have an identity matrix in here. That's what that's called, an identity matrix. We looked at that early on. And this right here, indeed, this is your solution. So this is your X, your Y, and your Z. And so step 4 is going to be to write your solution. So your solution is and you're going to write it in as a triple ordered pair with the X coming first. So -2, 7, 3. So what's nice is your calculator can do that for you in less than a minute. The only time that it really takes is inputting the matrix into your calculator. So your homework should be much quicker today. The only time-consuming part is inputting the matrices. Yes?
So when you use reduced row echelon form, does that solve it for pretty much all those problems? Like even if we went back and did examples?
Yep. Yep. The only thing that you need to know is, you know, how does this affect, for instance, let's go ahead and look at example 4. So example 4 is finding infinitely many solutions. Well, first of all, when you were doing your homework for page 1, did you come across any no solutions?
Yeah.
What happened? How did you know it was a no solution? Well, your Y's and your Z's canceled out, right? Your X terms didn't cancel out, but your Y's and your Z's terms canceled out. And then what you were left with, if it was 0 equals 0, then it should not have been a no solution. It probably looked like 0 equals 22 or something like that. And 0 equals 22 is a false statement. And so then you would have known for sure from there that you had no solution. It's possible you can have infinitely many solutions, and you should not have run across that over the weekend, but you will today. So let's look at what happens if, whoops, sorry.
There were infinitely many solutions.
Was there?
That was one of my answers.
Oh, was there one where, so did it then say something like 0 equals 0? Okay. With that as being a true statement, then yes, you would have infinitely many. But the question would be, how do you write that? And so we're going to talk today, how would you write that? Because with more solutions than an X and a Y, so if we tack on a Z, or in our case, we're going to also tack on a W, how does that look? It looks weird. So that's what we're going to do here. So step 1, let's go ahead and input, and if I were you, I'd write the directions as how to put this in your calculator. So step 1, we're going to input the augmented matrix into your calc. And so your augmented matrix in your calc is going to look like this. So let's start there. So clear your calc out. Second matrix. Scroll to edit. And then what's the dimensions of this matrix? It's still a 3 by 4, so we're just going to hit enter, enter, and then enter in your numbers. Always redouble check your matrix and make sure that you didn't input something in incorrectly, because that's going to be your error on the calculator, is inputting your matrix incorrectly. And then life will not be happy. So once we do that, then let's go back here to your directions. So then step 2, find R, R, E, F on calc. And I want to see what that RREF looks like. So, you know, this is what you're inputting, and you're going to tell me what pops out after you put this in. So go to second quit. So you're back to your main screen, and you have to do it from the main screen. Second matrix. Scroll 1 to the right to get to the math screen, and then you're scrolling down to find RREF. And then hit enter. And then you need to name matrix A, so second matrix, hit enter. Get in the habit of closing the parentheses and hit enter again. Do you see what happened here? Is this proper row echelon form?
No.
No. So, but notice that the entire bottom row here is what? 0. So remember what Michael was saying? Well, I got 0 equals 0. So what that's telling you is your variables have dropped out. And when this entire row here are zeros, then you know that you have the following. So let's go ahead and write what we got out on our notes. So this is what we had. If it's no solution, you're doing RREF on your calculator, it'll give you an error message. So it won't give you a matrix that looks like this, and you have to figure out, is it no solution or not? It'll give you an error. So on here, you're looking really for the fact that that row there is all zeros. It should be a really big clue. And so write out the equations that you got from that. So for the first row, it's telling you that you have an X term, no Y term, a Z term that's 3Z, and it equals 5. So write out what that equals. X equals, not equals, sorry, not yet. X plus 3Z is equal to 5, because we're missing the Y term on that one. Then the second row here, we're missing the X term, but we have a Y and a Z. So we have Y minus 2Z is equal to -2. So those are the only 2 equations we can write from that. And so then step 3, you are going to solve your equations for X and Y. So those equations that we just came up with, you're going to solve them for X and Y. So I want to get this X by itself. So what does x equal? Move the 3z to the other side. What do you get? Negative 3z plus 5. Is everybody okay with how I found that? All I did was get x by itself and move everything to the other side. So for y, you're going to get the y by itself. So y equals what? 2z minus 2. So your x, your y, and your z for your solution are all going to be in terms of z. It's an open solution. So your answer, your solution is this. So your x value per above is negative 3z plus 5. Your y value per above is 2z minus 2. And then comma z. So this becomes your solution. You have a triple ordered pair of expressions, all in terms of z. So that, because remember there's infinitely many solutions, so that if I let z equal 0, what would the x value be? If z is 0, it'd be 5. Plug it in, right? What would the y value be? Negative 2. So one of our infinitely many solutions would be 5, negative 2, 0. That'd be one solution. What if I let z equal 1? What's the x value going to be? 2. What's the y value going to be? 0. So we'd have 2, 0, 1 would be another ordered pair. I could go on and do this forever. You just choose values for z, plug them in for x and y, and that gives you an ordered pair. So MathXL might ask you to do that. They might tell you what they want z to be, and then you have to find the x and the y. Okay? All right, so then let's look at the other one here. We're not going to write as much for this other one. This other one is a 3 by 5 matrix. And so fortunately you don't have to solve this one by hand. It'd be a lot ugly. And notice that normally for 4 unknowns, we would need to have 4 equations. So that's one reason why there's infinitely many solutions on this one, because we don't have enough equations to solve. So let's go ahead and still input this into our calculator. So write yourself some directions. So the first thing you're going to do is you're going to find the RREF. So over here, I'm going to put the augmented matrix into my calculator. Let me move this over just a little bit so I can see the whole matrix. Okay, so I'm going to scroll over to edit. And what are the dimensions of this matrix? 3 by 5. So you want to put in a 3 enter and a 5 enter to give those dimensions, proper dimensions. And then start putting in your equations row by row. On that first row, you're missing the W here. What do you put in for that missing W? A 0. Good. Okay, so once you get your matrix in, now you're just going to find RREF. So do second quit to get back to your main screen. And you're going to do second matrix. Scroll 1 to the right to get to the math, and scroll down until you find RREF. And hit enter. Then select matrix A, so second matrix. Enter for A. Close the parentheses and hit enter again. What do you notice about this bottom row here? All zeros. So This one's slightly different, so let's go ahead and write what we got for that one. So again, that telltale all bottom row is 0. So the whole telltale bottom row is 0. So let's write the equations that we have to the right here. So the equations that we have in the first row, I have an x, no y, but I have a z, so plus z, plus 2w is equal to positive 1. Isn't that my first row? Isn't that what it's telling me? And then my second row, I don't have an x, but I do have a y, minus 2z minus w equals negative 1. And so I can solve the first equation for x in terms of z and w. And so that's what we're going to do. And so then I guess you can write yourself a note. Step 2, solve for x and y. So what is x equal to?
It's not,
Say that again.
it's not changing.
Oh. Did I lose my mirroring? No. Why didn't it? That's very odd. I don't know why. There it goes. It's just very slow. All right. So x is equal to what? Negative z minus 2w plus 1. Right? So the 1 didn't change signs. What does y equal? Positive 2z plus w minus 1. So once we solve for x and y, all that's left is our solution. So here's our solution. So we're going to write it in alphabetical order. So our x value is negative z minus 2w plus 1, comma. Our y value is 2z plus w minus 1, comma. We have no information on z or w, so z is z and w is w. And so unless your homework Math Excel gives you values for z and w, I mean, we could go all day and find infinite solutions to these, depending upon what you make z and w. All right, so any questions, issues, or concerns with that? Okay, so then the last thing that we're going to look at is example 5. So example 5, you could use what we just did. Reduce row echelon in your calculator and solve it just the same way. But there is another way to solve by using inverse matrices, which we talked about way at the beginning of page 1. And so if you'll recall that if I took matrix A and multiplied it by some value x and set it equal to matrix B, we discussed how an inverse matrix came about. So to solve for x, what did we do? Do you remember? What would you normally do to solve for x? Well, normally to solve for x, you divide by A, right? But we can't divide by matrices. We can't divide a matrix by a matrix. So we multiplied by 1 over A, right? Which is the same as a to the negative 1. So if I multiply both sides by a to the negative 1, wouldn't I end up with x equaling a to the negative 1 times matrix B. Well, what is matrix A and what is matrix B? Well, our matrix A is going to be this matrix right here, this 3 by 3 matrix, but without the X, Y's, and Z's. Jordan, are you taking notes? It's hard to fall asleep if you're taking notes. So this is called the coefficient matrix. And it's going to be without the X, Y's, and Z's. Then your X is actually going to be, X is going to end up being a matrix, but it's going to be all the coefficients. So I'll show you that in a minute. B is going to be this matrix right here. So this is matrix A, and this is going to be matrix B. So if we were to write this out, write out the coefficient matrix, you would have 2, 3, 2 going down in columns, 3, 3, 4, 2, 2, 1. So there's your coefficient matrix, and we're starting right here. We're going from right here. A times X equals B. So then times your X matrix is going to look like your variables. You're going to have X, Y, Z. And then that's going to equal your B matrix, which is your answer column. 1, 1, negative 2. So this becomes your A times X equals B. But on your calculator, this is how you're going to calculate it. You're going to take, that's my brother's birthday, yay. So you're going to take, to find your answer, you're going to first find, I'm trying to decide what color I want. You're going to first find a to the negative 1. And then your second step is going to really take that a to the negative 1 and multiply it times matrix B. And then you're going to get an answer column. So let's look at what that looks like. So on your calculator, clear this out. You can go to put in your, you've got to put in both of these matrices right here. So put in this coefficient matrix for A, and then you're skipping the X matrix, and you're going to put in this matrix for B. So let's go over here. Second matrix, let's edit our matrices. So go to edit and hit enter. And then your coefficient matrix is a what by what matrix? 3 by 3. And then to edit matrix B, you have to do second quit and go back into the matrix menu, second matrix. Scroll over to edit and make sure you scroll down and hit enter to edit matrix B, and make sure it says matrix B up here. And so matrix B, what is its dimensions? 3 by 1. So 3, enter, 1, enter. So then second quit. So I would expect to see this following work right here, because that's your input into the calculator. And then on your calculator, you're going to find the inverse matrix. So second matrix, name matrix A, and then you want to hit your x to the negative 1 key. So x to the negative 1, so it should read a to the negative 1. And then times, you want to name matrix B, so second matrix. Scroll down and enter for B, and then hit enter again. And ta-da, you get an answer column. And your answer column is 0, negative 1, 2. And so obviously this is going to be your X, your Y, and your Z. It goes alphabetically down. And so your last step, step 4, is your solution. So your solution, turn it sideways, 0, negative 1, and 2. So it's just another way to do the same thing. You're like, well, that's more work. That's true. Just another way to find that same solution. So any other issues, questions, or concerns on that? Yes?
Well, is that just, would you do it by hand? If you check it back, maybe
You won't have use of the calculator on the by hand portion of your test, so you won't be able to check it on your calculator. Darn it, right?